So, we're talking about evolution, and up to this point, we've really spent a lot of time discussing how natural selection can impact the way that those allele frequencies change from one generation to the next. But it's not just natural selection that plays a role in those changing allele frequencies when I'm looking at a particular population. And so, we're going to pick up today talking about a couple other mechanisms by which that sort of evolutionary or allele frequency change can occur. And one of those big ways that we can change the gene pool of a population is to allow gene flow to happen. And what that really is talking about is the movement of alleles from one population to another. So if I'm adding new alleles or taking alleles away from those populations, that's clearly going to affect the ratio of dominant alleles versus recessive alleles in that population that I'm studying. Now, one of the things that we've got to keep in mind is that it's not just this random allele that's suddenly going to show up in the population, because it really is a matter of individuals moving in or immigrating into a population or moving out of that population or emigrating, that is allowing those allele frequencies to change because those individuals are bringing that allele with them or taking it with them when they leave. So when we look at gene flow overall, it really is going to change the genetic diversity depending on whether that allele is coming in or that individual is moving in or moving out. Now, any gene flow that is moving into that population is going to naturally increase its genetic variation or its genetic diversity. And generally speaking, that's a good thing for that population to maintain its ability to stay healthy, genetically speaking. What we end up seeing, however, is when this gene flow stops. So somehow a population gets isolated from another. That lack of moving in and moving out, that lack of variation being added or taken away between those two populations can potentially cause them to evolve into different species. They can become so genetically different from each other because that flow has been stopped that we can actually get new species to show up. And that's part of why this topic shows up in evolution, because if those two populations get cut off, the gene flow stops, and the environmental influences of those two populations changes, we can get speciation, or these what used to be one species diverge into two new species now that these populations can't get to each other anymore. Genetic drift is another potential mechanism for evolution, but rather than gene flow sort of being predictable or natural selection being predictable, genetic drift causes the allele frequencies in those populations to change really from random chance. There's no real reason from a biological standpoint for why a particular allele becomes more common and why the other sort of drops off. And this only really happens when we talk about really small populations, because what ends up happening is the smaller and smaller that population is over time, you end up with such little genetic diversity that we really start talking about situations where individuals in that population, because it's so small, end up mating with relatives. And when we get to genetics, we'll talk about that sort of incest causing those recessive traits, particularly recessive traits that are harmful to these organisms, to actually sort of go up in frequency. Now, if it's a recessive trait and it's harmful, we would expect it to disappear from the population, right? If it's not doing any benefit to that individual, then they should be sort of getting weeded out of the population because those organisms shouldn't be the ones who are reproducing as often. But when we see with genetic drift, because that population is so small, that those more harmful recessive alleles actually increase instead. So when we look at how those populations can get small enough for genetic drift to actually become impactful, we really look at these two ideas of the bottleneck effect and the founder effect, and we'll talk through those in just a sec. But ultimately, genetic drift will cause the genetic diversity of those new populations to be dramatically reduced compared to where that original population started off. So let's